This Zoom session is being brought to you by the Fractal Odd Dyadic Horizon BL. All right, today we start with chapter 5, linear systems. And so 4 is due next Monday and afterwards next week. All right, now 5.1 is linear systems in a 2x2 variable, 2x2 linear systems. It's this form: ax plus by equals e, cx plus dy equals f, where a, b, c, d, e, and f are constant and x and y are the variables. It's called 2x2 because it has two equations in two variables. That should be enough. Well, usually it is, sometimes it's not. Here's an example: x plus y equals 10 and x minus y equals 4. Here a, b, and c are 1, d is -1, e and f are 10 and 4. So what two numbers add to 10 and differ by 4? Well, it turns out that 7 and 3 solve it. 7 plus 3 is 10, 7 minus 3 is 4. So 7 by 3 solves the system. Now, if you can graph x plus y equals 10 as this line going downwards diagonally, and this line here is this line going upwards diagonally. And so they meet in one and only one point, and its coordinates are 7 by 3. So 7 by 3 is a solution of the system and the intersection of the line graphs. Now, you can do other graphs as pairs of lines, or any other really. Here we have a system x plus y equals 10, x plus y equals 4. If you graph them, it's two parallel lines which never meet. They do not intersect. So there's no solution. That should make sense in this case because x plus y is being asked to be two different things. It can't. So when there's parallel lines, there's no solution. Or here's a system: x plus y equals 10, 2x plus 2y equals 20. These are equivalent equations. They mean the same thing. So the graph is the same line as overlapping lines, which intersect along their entire length. So there are many solutions. So you can have a system with one solution, no solutions, or many solutions. Like this, and like this. Intersection, parallel, or overlapping. Now, it turns out that when we get to Cramer's rule and the like, that no solution system has a solution at infinity, x equals 1 over 0. Here, overlapping solutions has infinitely many solutions. It's unfortunate that these two are as different as possible, really. No solutions and nothing but solutions. It's unfortunate the word infinity occurs in both of these descriptions. And I've seen people confuse them, and that's terrible. Please do not confuse solution at infinity with infinitely many solutions. I've seen people write down infinite solutions, and that could mean either of these. And so I always mark that as an X because it's ambiguous. In math, ambiguity is not your friend, unlike in Love and War, where ambiguity is your friend. That's because, unlike Love and War, mathematics has standards. So please, please, please do not write those words, infinite solutions. Distinguish between these two cases. Now, there are methods to solve linear systems. There's graphing, where you just draw the lines and see if they meet or not. And it's a terrible method. It's a Carpenter's solution. The accuracy of the solution is limited by the width of your pen and the grain of the wood on the table you're drawing on. And oh no, please don't do that. It doesn't. No, please don't. Now there are two other ways. There's substitution and there's eliminating variables. That's what I'll be covering here. Later, I'll be covering something called solution by matrices, which is basically eliminating variables done with fewer symbols, and something called Cramer's rule, which is a general system, very useful, I think, particularly with 2x2, a little less so with 3x3. In solution by substitution, you use one of the equations to solve for x or y in terms of the other variable. Then you substitute that into the other equation, get a one equation and one variable, solve that, then substitute back to get the other variable. So for example, x plus y equals 10 and x minus y equals 4. We already know the solutions are 7 by 3. Starting with this, we transpose x and get y equals 10 minus x. So here we have y in terms of x. Now we use this y here, substitute in here, get the equation x minus 10 minus x equals 4. This is one equation in one variable, and that we can solve by usual linear algebra methods. Okay, first we distribute the minus, x minus 10 plus x equals 4, transpose the 10, x plus x equals 4 plus 10, so 2x equals 14. Divide both sides by 2, x equals 14 halves, or 7. And then y, substitute back here, is 10 minus x, which is 3. And so x is 10, 7 and y equals 3. There's the solution. I request that in your homework, you please write the whole answer in one place. It does not do to write x equals 7 on this corner of the page and y equals 3 on the opposite order on the page, because that makes it more work for me. Please, I have enough work to do. Please do just that little bit of work just to make the answer clear, because clarity is the main virtue in mathematics. If you can write the thing clearly, you're most of the way to the solution. There's also a method called solution by elimination, where you eliminate variables. Here's how it works. You have two equations, a equals b and c equals d. Then you can combine them and you can rescale them. Combining is where you add first equation, a equals b, to a multiple of the other equation, kc equals kd. So a plus k times c equals b plus k times d. That's combining equations. You can also rescale an equation. If a equals b, then ka equals kb. K being any value pretty much for any value you choose. The idea of solution by elimination is to use these row operations to eliminate variables. For example, x plus y equals 10 and x minus y equals 4. If we add the equations and the x's add up to 2x, the y minus y cancels out, and 10 plus 4 is 14. So 2x equals 14, and we have eliminated the variable y. Now 2x equals 14, then you divide both sides by 2, and x equals 7, and we're done. On the left side, if we subtract the equations, x minus x cancels, y minus negative y is 2y, so 2y equals 10 minus 4 is 6. 2y equals 6, divide both sides by 2, and y equals 3. So 7 by 3 is the solution, as we got before. Right? So here's another example. 5x plus 2y equals 11, 7x plus 6y equals 9. The idea is we'll rescale the equation so variables line up this way, and then add or subtract to combine. So for example, let's rescale. You have a 2 and a 6. Let's multiply it, rescale by a 6 and a 2. If 5y x plus 2y equals 11, then rescale it by 6, get 30x plus 12y equals 66. If 7x plus 6y equals 9, then doubling everything on both sides, you get 14x plus 12y equals 18. The idea is that now we have a 12y here and here. 2 times 6 equals 6 times 2. So since these are lined up, we combine by subtracting, the y's cancel. Subtracting, 30x minus 14x is 16x, 12 minus 12y cancels, 66 minus 18 is 48. So 16x equals 48, divide both sides by 16, x equals 48 over 16, which is 3. Here, we have a 5 and a 7 here and here for x, so rescale by a 7 and a 5 to line them up. This equation, rescaled by 7, is 35x plus 14y equals 77. This equation, rescaled by 5, is 35x plus 30y equals 45. Subtracting, the 35x's cancel. 14y minus 13y is minus 16y. 77 minus 45 is 32. Minus 16y equals 32. Then divide both sides by negative 16. So y equals 32 over negative 16. So y is negative 2. And the solution is 3 by negative 2. All right, here's some examples. Y equals 3x and x plus y equals 8. For this one, this is made for substitution because here we have y in terms of x already. So plugging in a 3x for a y here, you get x plus 3x equals 8. So 4x equals 8. So divided by 4, x equals 8/4 or 2. You substitute back into here, y equals 3 times 2 is 6. So the solution is 2 by 6. Okay, here's x plus 2y equals 6, 3x minus y equals negative 10. We could use either elimination or substitution. In this case, I choose to use substitution. You can do either way. Since x equals 2y plus 6, then x equals 6 minus 2y. Plug that value of x into here. So 6 minus 2y into here. You get 3 times 6 minus 2y. That minus y equals negative 10. So, okay, the rest is algebra. Let's distribute the 3. 18 minus 6y minus y is negative 10. Transpose the 18. Minus 6y minus y equals negative 10 minus 18. So negative 7y equals negative 28. Divide both sides by negative 4. So y equals negative 28 over negative 7, which is positive 4. Substitute that value of y back in here. X equals 6 minus 2 times 4. And so I'll get 6 minus 8, or negative 2. Therefore, x is negative 2 and y equals 4. Here, we have x minus y is 7, x plus y is 11. All right, easy enough. If we add the equations, x plus x is 2x, minus y plus y cancels. 7 plus 11 is 18. 2y equals 18. Divide both sides by negative 2, and you get x equals 9. If instead we subtract the equations, x minus x cancels. Negative y minus y is negative 2y. 7 minus 11 is negative 4. Negative 2y is negative 4. Divide both sides by negative 2 and get y equals 2. So the solution is 9 by 2. Now here we have a rather messier one. Twice a plus b equals 94. 4 times a minus 9 equals 3b minus 23. Oh boy, we have to do some cancel out, some simplification, some distributing. Distributing the 2 here, get 2a plus 2b equals 94. Distributing the 4 here, get 4a minus 36 equals 3b minus 23. Okay, for this one, let's move the 36 to the right and the 3b to the left by appropriate additions and subtractions. So you get this 2 by 2 system. 2a plus 2b equals 94 directly from here. And from here you get 4a minus 3b equals 23, negative 23 plus 36 makes 13. 2a plus 2b equals 94. 4a minus 3b equals 13. Okay, let's see now. Let's just, you have a 2 and a 4. We could even them out by multiplying by 2 and by 1. If you do that, this times the 2 gets you 4a plus 4b equals 188. This times the 1 is the 4a minus 3b equals 13. So the a's are lined up, so you can eliminate them by subtracting. Subtract this equation minus this equation. The a's cancel. 4b minus negative 3b is 4b plus 3b is 7b. 188 minus 13 is 175. So 7b equals 175. So b equals 175 over 7. So b equals 25. Or I'm going to define an a. Well, we have a 2 and a 3 here. So let's rescale by a 3 and a 2 to make the b's line up. This times 3 throughout is 6a plus 6b equals 282. This times 2 throughout is 8a minus 6b equals 26. So you have a 6b and a minus 6b. These we can eliminate by adding the equations. Adding 6a plus 8a is 14a. 6b minus 6b is 0, nothing. 286 plus 282 plus 26 is 308. 14a equals 308. Divide by 14. A equals 308 minus over 14 equals 22. So the solution is A is 22, B is 25. All right. This one, a bit special. This and the next one. 0.16x plus 0.08y equals 0.32. 2x minus 4 equals y. Okay, fine. We'll rescale this by 25 just to get rid of the decimal points. And that way we get 4x minus 2y equals 8. Transposing y to the left and 4 to the right, you get 2x minus y equals 4. Notice something here. 4x minus 2y equals 8. 2x minus y equals 4. These two equations are proportionate to each other. If we rescale this by 1, you get 4x minus 2y equals 8. If If you rescale this by -2, you get -4x plus 2y equals -8. If you combine by adding, it all cancels out. 0 equals 0. Now, when you get a 0 equals 0, that means this original system had some redundant equations. It's telling you things you already know, just as like you know that 0 equals 0. And if you graph them, you get the same line twice, overlapping lines. Therefore, there are many solutions. So if you get overlapping lines or 0 equals 0 when you do elimination, then there are many solutions. Here we have a rather annoying one. X over 4 equals 1 plus y over 5. X equals 4/5 y plus 10. Well, these denominators are annoying, so let's multiply this throughout by 20 and this throughout by 5. When you do that, you get 5x equals 20 plus 4y, and 5x 4 times y plus 10. Distribute this and you get, so 5x minus 4y equals 20. This when you transpose the 4y. And here you get 5x equals 4y plus 40. Transpose the 4y here, and you get 5x minus 4y equals 40, and 5x minus 4y equals 20. Well, I can see we're heading for trouble because 5x minus 4y can't be two separate things. If you subtract the equations, then everything cancels on the left, and you get 0. And 20 minus 40 equals -20, and you get 0 equals -20, which it isn't. It's not equal to 0. 0 is not equal to 20. In the before times when I would be before my students and I'd get an equation 0 equals, let's say, +20, I'd ask, gee, is 0 equal to 20? And I'd reach into my pocket and turn it inside out, and there's nothing in there. And I said, nope. I keep hoping I would get a $20 bill that way, and it never, ever happens. Anyhow, since 0 is not equal to 20, there's no solution. And in fact, these two equations, when graphed, give you parallel lines. So no answer. So sometimes you get, after elimination, you get 0 equals 0. That means many solutions, overlapping lines. And sometimes after elimination, you get 0 equals non-zero, which is parallel lines, no solution. Finally, here's one. Find two numbers that sum to 34 and differ by 10. All right, so this is a word problem. So the hard part is the first step, writing the equations. So let x be equal to the larger number and y equal to the other number. Then their sum is x plus y, which equals 34. And their difference, putting the big number first, is x minus y, and that equals 10. X plus y is 34, x minus y equals 10. This solves by elimination quite quickly. If you add the equations, the x's add up to 2x, the y's cancel, and 34 plus 10 is 44. 2x equals 44, x equals 44 over 2, so x is 22. If you subtract the equations, then the x's cancel, eliminating x. Y minus negative y is 2y. 34 minus 10 is 24. 2y equals 24. So divide by 2 and get y equals 24 over 2, or 12. So the two numbers that sum to 34 and differ by 10 are 22 and 12.